Up first, we have Northcoders, so I'll pass the mic to Joe and Kat. Best of luck.
I'm going to resist the urge to break into my world-famous Whitney Houston impersonation. Hello, everyone. Welcome. Thanks for coming. Thanks to Burns Sheehan for organising this event. You're very welcome to Northcoders. We are perhaps rather different from some of the companies that you work for. We don't produce software. We produce people who produce software. So, nonetheless, we have an interest in microservices, and we have the idea of microservices has had quite a large influence on how we do some of our teaching and some of our ideas. So we're going to tell you about that tonight. First of all, let me introduce us. I'm Joe Mulvey. I'm actually a Northcoders. Ooh, let's move on. Yeah, I'm a Northcoders graduate myself. I left Northcoders about 6 years ago to go to work for AutoTrader as a data engineer there. Subsequently, I went to Greensill, a company not unknown to at least one of our other speakers this evening, Matthias, where indeed we worked on some microservices material there. Perhaps we'll hear about it. And thereafter, I worked in consultancy with Inawisdom, now part of the Cognizant Group. And I've previously been a teacher, so this is kind of my sweet spot, teaching and indeed doing some software development. So excellent. Let's hear about Kat.
Hello, I'm Kat, and I graduated from the software bootcamp about a year ago. I joined the teaching stream straight after, and then I joined data engineering in October, where I support our students and also help develop the curriculum. That's me.
Excellent. Right, so let's tell you about the data manifesto. We teach data engineers here now at Northcoders. As you've heard, we've just had our second data engineering cohort graduate, and we've got the third one in progress. And one of the things we teach them is about the shape of a good data-intensive application. And we have what we call the data manifesto. And the data manifesto is a set of principles that we want students to bear in mind when they are building data-intensive applications. And there are a couple of principles here, 7 in fact. First of all, is this application going to be useful? Does it actually do what the business or your client needs it to do? Second, is it reliable? Does it actually work? Pretty basic question. Third, is it observable? And obviously, when we're building things in the cloud, that's an especially opposite question. We need to be able to observe the performance and any potential problems. Fourth, is it resilient? Will the unexpected change of a data schema or some unexpected event cause a catastrophic failure, or will it survive through the failure of individual components? Is it organized? Can users find the data that they need in potentially a very large data platform? And indeed, can software engineers find the components that they need to fix within potentially a very complex application? Is it adaptable? If the business suddenly decide that the requirements have changed, are we going to be able to build new things or develop the things that we have? And finally, of course, is it secure? Okay, this is really basic in today's world. So, all of this is motivated by observation of a number of anti-patterns that we see out there in the real world. The first one we might call the white elephant. And of course, this isn't a data engineering specific issue. There have been some high-profile cases, particularly in the public sector, for example, where organizations have built very complex applications and platforms that cost a lot of money, take a long time to build, have some amazing tools in there, all the toys are included, but where no real functionality that's useful to the business has been delivered. And it can happen in the public and the private sector as well. So it's not unique to the public sector, but it's a very common theme out there, very common dysfunction of the architecture process. It can happen for a number of reasons. It can happen perhaps because the communication between developers and users has not been adequate and requirements have changed, for example. Or it could be the dreaded design by CV, where people have wanted to create with the latest tool rather than creating functionality that's useful.
So the next one is the swamp. So this is an application that takes years to build, and it has all the information, and some of that information is really, really important, but it's not very well documented. Nobody knows where to find what they need, and they get completely lost.
The third major anti-pattern we observe is the house of cards, or what might be called Project Jenga. Okay, you've seen this before as well. You've got an application that works, that is valued by the business, that absolutely delivers what's needed, until something has to be fixed or upgraded or adapted. Some small change that all of a sudden, the effects of which will have to ripple through the whole application and start to cause downstream problems. Okay, so the application is built in a brittle way, and as time goes on, it becomes more and more brittle and more susceptible to failure. Okay, so what have microservices got to offer in the way of fixing these issues? Well, first of all, in terms of usefulness, when we're creating small components, we can develop functionality incrementally. We can interact with our business users and say, we've developed this small single piece of functionality, is it what you need? If the answer is no, then it's not terribly expensive to retract, redesign, and rebuild that small thing, rather than delivering a huge monolith, which after a protracted period of time, which doesn't do what's required. These smaller components are more susceptible to be tested. We tend to use functional programming paradigms in data engineering, so using stateless components. So it's really straightforward to unit test these small units, and therefore we can deliver with high confidence reliable software. Small components connected perhaps by streaming services. Within those interfaces between components, we can place observability tools and track the progress of data through our application more easily than if the data is disappearing into a monolith and coming out the other side without further observation. Resilience, the ideas of loose coupling and stateless components allow for recovery from failures. So one component is not going to destroy downstream components. The failure of one component is not going to destroy downstream components. And again, because of these components are small, they can be adapted easily. We can scale them. We can add in functionality. We don't have to pull apart an entire application in order to do that. Not everything's an advantage. Microservice architecture can be complex. So it can be tricky to keep track of what the application is doing and understanding the architecture. So documentation is really crucial. You have to put in probably additional effort there. Security is probably neutral. These small components can be tested for security. We can use unit testing for security, but we also have the potential for a greater attack surface. Okay, so I'd call that one neutral.
So how does this tie in with our students? So microservices give our students really crucial, hands-on experience of creating and deploying data applications. Our students usually work in groups of 5 or 6 to create a lakehouse data platform, and then they showcase their work at a graduation ceremony, and they can show their fellow students their solution, and it just gives them really good experience with it. So this is what their project is based on, and Joe's going to talk more about it.
Okay, so we have a fictional scenario. We suggest to our students that they are working as consultants for a company called Totesis that makes tote bags, customized tote bags. Okay, you know the kind of cheap rubbish that is given to you by disreputable companies at marketing events, right? So they have a bunch of operational systems there on the left that have various data sources, perhaps a relational database, NoSQL databases, perhaps they have interfaces to third-party APIs. What they lack is a data platform that unifies all of their data for analytical purposes. So they have to extract data from all of these sources, put them into a platform using a kind of lakehouse pattern where we have unstructured and structured warehouse data, and do the transformation processes associated with that, all of which is mediated by correct DevOps kind of infrastructure as code, CI/CD, and the rest, and we make the data available to a variety of consumers. Now, in reality, our students are not going to be able to deliver a full-blown, fully functioning, all-service data platform in the time that we give them, and they're novices, of course, as well, but they do produce part of this. They certainly ingest from relational database systems, write microservices that will extract from the data sources that the functioning simulated data sources that we provide, and then produce transformation and loading processes that are separate microservices deployed with correct DevOps infrastructure.
So the microservices our students use, we introduce them to AWS, and we do event-driven architecture. So they'll use like EventBridge to set triggers to automate the process. They'll use Lambdas to do the microservice computing. S3 for storage, so putting their process information into buckets, and then they'll load it to a prepared warehouse. So they'll use tools like Terraform to do infrastructure as code, where they can deploy certain components. And then finally, they'll use GitHub Actions to do CI/CD.
So, what do our students get out of this? Well, in the end, we should have students who have good foundational skills in a relevant language, and for us, that's Python. They should understand the basics of data modeling and data architecture. They should have strong SQL skills. They should be pretty good at the cloud and DevOps type engineering. And what we're trying to teach here is tech agnostic principles rather than specific software choices. So we're not, for example, trying to teach the Databricks stack or the Snowflake stack. We're trying to introduce them to fundamental ideas using open source software wherever we can, so that they understand why they're doing things rather than using specific tools. And finally, of course, more than anything, we give them practical experience of creating a data-intensive application, and that, more than anything, is the valuable experience that they come away from our course having received. And that's it. Do we have any questions?